Hello and welcome again to an INB382 demo video. In this case, we're now looking at doing global illumination using the latest tools that are inherent in Unity 5 from the Cambridge University spin-off known as GMRX, and their Enlightened system, which is incorporated into Unity. This is a very simple demo I'm covering here. I'm not going to go into any great detail. I cover the theory in the lecture around radiosity, the use of spherical harmonics, which we'll probably touch on in the tutorial regarding using light probes. I just wanted to have an initial demo here so that we can get a feel for just how to use the global illumination systems inside of Unity. So first of all, I created just an empty project. I then saved the scene as global illumination. So it's just got a standard camera over here. And in fact, I'll just highlight that down here. It's got their sky dome, which is, the skybox, which is a standard sort of skybox that comes with the system. I'm not doing anything special here. And a directional light. We need a light source. This feeds into the mechanisms used to provide the global illumination. So this one's a directional light. It's the default that comes with the system. I haven't changed anything here. Everything is just bog standard, which I like. It works straight out of the box, and so I'm quite impressed with how simple it is to set up your global illumination here. Now the artistry is another matter. I don't cover that. So if you want to learn more advanced topics in this, then yeah, play with the parameters to your heart's content. Get a nice beefy machine and let it do the work for you. So I've just put a cube here just to begin the whole process, and I've used that as my sort of basis just because I wanted to save some time in this video with me stuffing around putting in cubes and so forth. It's all a bit silly. So first of all, Unity now uses this standard shader mechanism. As you can see down here, the default material for the object is the standard shader. I can't modify that on this instance of the object. What I need to do is create a Jim Dandy material. Here we go. So we're just going to call that red, just for the sake of it. And then, because it's already got the shader attached to it, there's no custom shading here because to access the diffuse illumination in the scene gets a bit tricky within custom shaders because you have to integrate that with the surface shading mechanisms that are present inside the standard shader. So for our unit, this will suffice as some insight into how to use global illumination, and it gives you something to play with. Because in the end, I'm expecting that you're not going to write that many custom shaders in your games. The whole intention of the unit is to understand how it can be done and the theory behind it. So in this case, it's such a complex thing to implement a global illumination system, we may as well use the tools that are in Unity just to illustrate the theory. Then you can go from there to learn more about the techniques involved and some of the subtleties involved. Anyway, so we're using standard custom shaders. I'm not going to do anything special here. Now, the material is a physics-based or physically based material with energy preservation, so things don't bloom and go a bit weird like they do with normal custom shaders. So if you want to change its color, you change the albedo or the diffuse reflective component as a Libertine reflector. So I'm just going to make it red. And that's going to look very pretty. So now we have our red material. That's all great. I'm going to drop that onto the floor there, and we've now got our red material using the system. So the next thing, let's create a couple of cubes and just move them around. So boom. Yep, that sits there nicely. How about I create another one? And let's just move it around. So you note here, it's already putting out shadows. So if I was to play around with this, it's a directional light. So unless I rotate it, I'm not going to get much difference in the shadows. So if I move the shadows around, you can see the skybox is being rendered nicely onto the surfaces of these objects with its default material. The problem is, of course, I really want to show some of the blending effects that occur with global illumination. So I'm going to change the colors here and just add some different materials so we can get some sort of maximal illustrative color bleeding. I'm going to make this one a blue one. Or green, that's another favorite. So I go over here, put in the blue space. This is now a really bright blue material. And I drop it on the scene there. There's our bright blue material. So far it's not doing any bleeding. You can see it's not really giving me any sense of contributing there. So a couple of things to get it running. First of all, you need the lighting dialog here. And one of the things you'll find here is that there are lots of parameters. I'm just going to cover a couple of things. So with the lighting tool, you go up to Window, Lighting. And that brings it out, and then you can drop it into, once you choose that, you can drop it over here into the inspector and have it permanently there for you to play around with. So there's a number of forms of illumination. So I will have mentioned in the lecture about the baked illumination, which is sort of your old school, let's run a path tracing system in the background and generate a bucket load of radiosity solutions. That's all well and good. We don't want that. We want the general global illumination using just the default setup here. Atlas size is about 1024 for the actual light mapping that's going on in the background. So I'm just using default parameters, and that's enough for us to just illustrate the system working. So now we have our general GI working, and we can choose a skybox. So one of the things here, you can choose lots of skyboxes to do your job. So I've got the default skybox here. The sun that is being used, you select the light in the scene you wish to use. So it's going to be this directional light, so it's the sun in the scene. That's going to control the global illumination solutions. And that's about all your setup. On the main camera, we will see here there's nothing particularly crazy to set up. It's a standard sort of camera in Unity 5, so nothing really to display here that's crazy. Now, one of the key things we're going to have to do here is incorporate the cubes into the global illumination scheme. So one of the things that is a constraint on this system is that you need static objects can only be used in the global illumination system. Dynamic objects can be used using light probes, and we'll get to that in the tutorial, so I'll get you to do a little exercise there. But here, all it is about is just, okay, let's have some objects in the scene and have them respond to each other. At the moment they're not responding because they're not marked as static, so they're not able to contribute to the scene. The bottom cube is, so what I will do is just highlight them all and make them all static. And what you'll find in the bottom right hand corner here is that a radiosity solution runs in the background. So it's all out of your control. Once you want it, it just runs. And then all of a sudden you notice that first of all this cube is now red because light is bouncing off the bottom surface here. And interestingly enough, we have our blue cube here, which, as you can see, I moved the object. So they're set as static, but obviously if the editor moves things, it triggers a thread in the background, runs the global illumination system again, and lo and behold, we have color bleeding between the cubes. So this is where we're starting to get those subtle lighting effects that I've talked about in the lecture, all done for you by Unity 5. Now this is for static scenes. It's not baked, it's computed in the background and it's ready, and there's a visibility data structure runs in the background to provide the form factor analysis for the radiosity solution that I talk about in the lecture. And that's about it. So, but this is for static objects. If we want to have dynamic objects in the scene, then we need to have light probes incorporated into the environment. And at that stage, that means we then use the spherical harmonic representations that I talk about in the lecture to provide a dynamic model of light into the scene. And I'll just get you to do that in the tutorial that comes up in a week. So that's the end of this little demo. It's actually quite quick to set up because the tools are available and made easy to use inside of Unity. There are much more subtle effects that can occur, but you have to tweak the variables. But as you can see, it computes for you, for your static systems here, a dynamic lighting solution. And actually, one thing I missed here is that the lights are actually dynamic, but the objects are static. So if we go back, play with the light source, we get some interesting effects that happen in real time. Shadowing works. See the color bleeding goes a bit weird. It's all quite nice. So as you can see, this is quite handy for setting up global illumination. And you know, I have to say, after 23 years of being in computer graphics, it's pretty impressive that I can now run this on a MacBook Air and have quite a sweet solution for my scenes, all integrated into a game development environment for scripting. So obviously the field has matured, and that's it. So thank you very much for this video, watching this video, and that's the end of the video.